Hi, if you are worried that the at least or at most once delivery semantics can introduce some data quality issues, there is a good news, because with the idempotency, you can ensure that the data, even if this weak delivery semantic levels, is delivered exactly once. How? Before talking about how, let's recall some basics of an idempotent function. So, as you can see here, we are having an x parameter and a function called f. So the idea of an idempotent function is to give always the same result for multiple calls of this function on x as for the single execution of this function on x. More specifically, if you want to more detailed example, if we want to get an absolute numbers for some value and we pass a -1, whenever you call this absolute function 20 times or single time, you will always get the same result. And there is the same idea in data world. So you have some function writing data, right? That corresponds here, for example, corresponds here to the jobs writing the data. Even if the job is read-write 3 times, it will always end up with the result of a single write that way. And how to achieve it with data pipelines? So there is the first approach, which is not ideal because it stores the already processed data in a local or distributed storage and tries to deduplicate it by some idempotent ID generated on the streaming broker. But why it's not ideal? So let's first see the perfect scenario. So now we have the already processed data here with 1 and 2. And now if we are processing 1 again, the data processing jobs verifies whether this 1 is already present in the already processed data storage. And if it is the case, it will simply not write it again. But there's this gotcha, it leads to the at most delivery semantic, because if this checkpoint step succeeds but the data delivery fails, then we will not be able to integrate this failed record again. So it's not perfect. It may be working maybe 99% of the time, depending on the SLA of your streaming broker. It may be a good start, but it's far away from being a perfect solution. And there is a variation for that tries to reduce a little bit the storage. And this reduction consists of using the window aspect on the deduplication. So here we are considering a window like, for example, time-based window of 10 minutes. And if within these 10 minutes we get the same records, we will be able to deduplicate them correctly. But of course, is a trade-off, and each trade-off has some implications and consequences. Here the consequence is that if you retry the delivery of the record number 1 after the window period, you will simply ingest it again to the system, so it's not a perfect solution either. A much more stable and resilient approach is called name-based. So we can imagine we have a data source and we are reading data periodically. So here we are getting data between 10 and 1040. And now in our storage, we are generating files. We are including this data fetch information in the names. So again, if you reply the job somehow and you don't want to produce new data, we will always get the same file. And of course, it happens for other periods of time. So there is always one copy of the data. The name can be either the period of time, it can be also, for example, a table name. And it's very important to keep in mind that it's based on immutable data properties, so something that can't change. For example, if you decide to reply the generation for this file, you will have the period of 10 to 1040 stored in your metadata store. So even though you reply it 2 days after, you will always target the same data and always write the same output. Another approach is the merge operation. So the idea is to either update an existing record or add a new record if it doesn't match in the database. So here the key point is that the ID you use in the merge must be idempotent, because if you you create an ID that relies on some temporal context, like for example current time, then it will not be idempotent even if you have the same data to merge. You will not detect that fact as a update, but rather as an insert, and so lead to insert the duplicates. And also it's a much more compute intensive, because generally you don't operate on the metadata layer, like for example for the naming approach. Here we were operating on names of the files, not on the data directly. And here we are mostly dealing with a SQL queries on something that has to be executed on some compute storage. And a little variation for the names is alias. So we have our data processing job reading data from some source and writing alias, versioned data. The trick is that this data is retrieved from a single point. So for example, here we have files, and the single point will be a symbolic link. And now if we need to reprocess the data, or by accident we reprocessed it, we will simply need to update or not the symbolic link to the new version of the data. So here this exposition, it's the exposition point. This part is a little bit hidden in your system. It's your internal logic. Your customers only know about this thing. And here we are talking about reference links, but on the database you can also implement it with all kinds of views, materialized or not materialized, where you will simply change the underlying table that participates in the view construction. So the point is all that required? The answer is no. If your data consumers can deal with duplicates, or having duplicates, it's not a big deal. And of course, at least once delivery semantic is better than at most once, because you always deliver data to you. Then, yeah, all this idempotency approach may be a little bit over engineering. But if you want to ensure a better quality of your data and reduce the number or eliminate the number of duplicates, even if in case of reprocessing, and it's very important, especially in batch pipelines when you want to reprocess data and, for example, fix some errors, yeah, the idempotency can be very, very useful. So that was my key takeaway from this lesson. Thank you very much, and see you in the next lesson.